Hi guys, I wanted to welcome you back. Welcome after a whole month of not being in school. I hope that you have taken advantage of the month. If you had missing work, I hope that you spent some time exercising your brain. But most of all, I hope that you had a relaxing break. Welcome back, and we are going to jump right into what we're doing. So before we left for break, we studied meteorology, which was weather, and now we're going to kind of look at how humans are impacting the weather and climate and atmosphere. So the very first thing on your module is a copy of your notebook. If you do not have it and you like to print it off, it's right there for you. If you are face-to-face with me, then don't worry about it. I will get you one. The next thing on your list is a announcement, sort of. So last quarter, we did lock the assignments 14 days after they were due. Locking means that you can't go back and do them. They're locked. So to try and increase work being completed daily in science, we are now going to close and lock our assignments 7 days after being assigned. That means if the assignment was due on January 4th of 2021, it will lock and can't be turned in after January 11th, 2021 at 11:59 p.m. Your goal as a student, even online, is to be completing assignments daily. That is much better for your mental health, for your learning abilities, and just to overall give you a better chance of success for this course. We know and understand as teachers that internet issues happen. That's why you do have the 7 days. We're not telling you it needs to be due exactly, or it needs to be done that day, although it really should be. So if something happens, you've got a little bit of wiggle room. But again, that wiggle room is 7 days, very strict. So we're going to start this new year off right by striving to be engaged and successful students. To finish this, it's not graded. I just need you to do it. I need you to type, I understand that the assignments will lock 7 days after being assigned, just so you know, and you're held accountable a little bit to getting your work done. Now, the next thing we're going to do today is our climate classification notes. So again, we got to learn what climate is. So we're going to be doing this note page. If you are online, I've got a copy of the fill in the blank ones for you. In order to edit it, again, you need to make your own copy. Same kind of deal as before. Remember, sometimes it's better to screenshot than it is to turn in the document. This is a document, so it should be fine as long as you save your changes on Google Docs. Okay, jumping right into it though. Your bell ringer today is to recall what the difference between weather and climate is. Pause this and get yourself something to write with and write down what you think the difference is, or if you remember. To give your answer, remember we had that clever little saying that weather is what, or climate is what you expect to happen, weather is what actually happens. So in general, weather is the day-to-day conditions of the atmosphere, while climate is an overall average of what the atmosphere is doing at that time and in that certain location. So climate is what you expect, weather is what you get. We're going to start right off with our notes. Again, climate is that average condition of a region or the weather pattern that occur over many years or months. So again, this is their average. It might not be exactly what's happening. It might not be that low temperature that you're seeing outside right now. It is just what we expect due to that region. There are a couple of factors that we use to determine climate. So we generally look at the temperature patterns for that region as well as the precipitation. So how hot or cold it is in that region or how much rainfall is happening. Again, I am breezing through these. The great thing about having a video lecture is that you can pause it whenever you need to write down your answers. We have a couple other factors that affect our climate that cause this temperature and precipitation difference between each of the regions. The very first one, and in general what we do expect and look at, is latitude, or the distance from the equator, or how close you are to the poles, right? We all can kind of generally understand that as we go north, we're going to have colder temperatures for longer periods of time until eventually we get to the North Pole or the South Pole, depending on which direction you're going, and it's cold all the time. This is determined because of the amount of solar energy received and the prevailing wind belts. So we know at the equator, we've learned in our astronomy unit, we touched on it last unit, and we're going to touch on it again, that with the Earth, the equator region is receiving a lot more of that direct sunlight, meaning that it's generally going to be warmer, and then that uneven heating of the earth is what actually causes our wind belts. We talked about that in our last unit. This should be sounding familiar to you. So the very first thing that affects our climate is our latitude, but that's not it. We have more than just latitude. If we didn't, we would have a very boring looking climate system of Earth. The other thing another factor that affects climate is our wind patterns. So our wind patterns, again, are caused by that unequal heating. Remember, we talked about we have 6 wind cells in the Earth due to the Coriolis effect, or that spinning that we have. We have 6 instead of just 2. Generally, if we didn't have any spinning, our warm air would go to the poles, rise, go to the poles, sink, come back down to the equator, and we would just have 2 wind cells. We have 6 because we are spinning. And these wind patterns that we have, the global ones, they affect our humidity, so how much water vapor is in the air. They affect our precipitation, our temperature, and our cloud coverage. So again, that all plays into our climate, or the region of the climate of the region. A couple other factors that affect our climate: the elevation. So the higher elevation, the colder the climate generally. Remember, elevation is how far you are from sea level. You think about a mountain. Hopefully, if it's wintertime, has a nice snowy top, while the valley might not be snowy. So that elevation can cause a difference, especially if we're talking about a very, very large mountain. Topography also can cause a difference in our climate. Remember, mountains really play a role in our climate for temperature and precipitation over that area. Remember, I don't know if we talked exactly about this, but if you're on a mountain and you have wind blowing towards that mountain, the mountain side that the wind is blowing towards is actually going to get a lot of rain, while that other side is going to be very, very dry in climate. That's called the mountain effect, something like that. But that also affects our climate. So what is going on in the region as far as how high, and also, do we have mountains, do we have rivers, do we have lakes, and so forth, can affect our temperature and precipitation, therefore overall climate. Again, large bodies of water can really affect our climate. So they hold, because water has a specific heat that is 1, and generally that is higher than the land, so it takes more energy to raise or lessen the temperature of water. It can really play a part on the weather of the coastal regions or lake regions. Large bodies of water, so like our Great Lakes up there in Michigan, Ohio, Pennsylvania, and Minnesota right here. Those are having their climate is affected by their large body of water. Excuse me. So they can not only affect the temperature of the region, but also the humidity. Again, because the temperature of the water body influences the temperature of the air above it. So if the water is really, really warm, it's going to make the air around it really warm. If it's really cold, it's going to make the air around it really cold. So that is often why our temperatures in coastal North Carolina are much warmer than inland at the same latitude, because we are affected, even being an hour from the ocean, we are affected by the heat of the ocean, or the heat that it holds. Again, not only just the water in general, but that ocean current can also bring warm or cold currents to a region. We talked about this when we were talking about the climate of Great Britain. So Great Britain, based on the region, is supposed to be a lot colder than it is, but because the global conveyor belt passes by and brings a nice warm current, Great Britain is actually rainier and warmer than it should be based on its latitude. Lastly, for our natural effects of climate, vegetation can play a huge effect on our climate. So vegetation can affect the temperatures and the humidity patterns in the area, because it influences how much energy is absorbed. So if you have a lot of vegetation, you're likely going to have higher temperatures and a little bit more humid because of that transpiration of water vapor out of the plant stomata. So vegetation can play a role again as well on the climate. We have a couple other natural processes like volcano eruptions. So the presence of a volcano, like the dust and the gases in the air, affects the amount of energy that is reflected back into space. It can cause cooler climates. Think also the dinosaurs and how they stopped being because a meteor came and filled the sky with dust and ash, and that decreased the climate, causing the giant reptilian species to be extinct or to go extinct. And because plants couldn't photosynthesize. So there's a lot of issues with ash and dust in the air. Again, ocean currents, the changes in ocean circulation can cause the climate to change. So if those were ever to change, we might see different climates. Other things can be solar activity like flares and Earth's motions like what season it is. And then again, like we've talked about, there's a difference between a coastal climate and an inland climate. In warm seasons, areas closer to larger bodies of water tend to have a more moderate temperature compared to those inland bodies of water, again, are slow to heat and hold heat longer than solid rocks. So that means in colder seasons, coastal areas are warmer than inland since water loses heat more slowly. I would take a second to reread this by yourself, really get and understand this. One of the ways that we classify our different climates is by the Köppen climate classification system. There are 5 key climate groups based on this type of classification. Again, different scientists classify them differently. This is just one way. This is what we're going to learn today. So we have A, moist tropical climates, dry climates, moist mid-latitude climates with mild winters, moist mid-latitude climates with colder winters, and polar climates. Excuse me. Moist tropical climates first. So these are climates without winters. So think like your rainforest, your kind of Florida regions, I would say, anything really close to that equator. So they include, or they have characteristics, they're usually over 18 degrees Celsius of a mean temperature all year long. It's got high precipitation, about 200 centimeters per year. Again, we have 2 types. We have wet tropical, such as like our rainforest in Brazil, and then we have a wet dry climate, or wet dry tropical like a savanna in Africa. So they can be seasonally wet or they can be wet all the time, but again, at some point in their year, they've got a wet season. And then we have our dry climates. So these are characterized by yearly precipitation, not having a lot of precipitation, but also having a great potential loss of water by evaporation. So think your deserts like the Sahara in Africa. So sometimes you do have precipitation in a desert, but the difference here is that our precipitation that happens is less than what is evaporated, so we get very, very dry landscapes and the plants that go along with those. Next, we have our moist mid-latitude climates, and these are characterized by location and type of winter. So again, we have our mild winters, which is anywhere between 3 degrees Celsius and 18 degrees Celsius as an average, and they happen from around 30 to 50 degrees latitude, mainly on the eastern and western borders of most continents. And then we also have our regions that have severe winters where their temperatures will dip lower than 3 degrees Celsius, and these are areas affected more by the Arctic air masses. For the most part in the U.S., we have a lot of mild winter, moist latitude climates. We don't really have any of those severe winters. That would be more like Siberia and up into parts of Canada. And lastly, we have our polar climates. These are characterized by mean temperatures below 10 degrees Celsius in the warmest of months. So this is like Arctic and Antarctic, definitely very cold. You would find organisms such as penguins, polar bears, lots of marine mammals. Your plant base here, or what was green, would be less so plant-looking trees, shrubs, and grasses, and more so algae-based and phytoplankton-based. So think very marine systems here, very dependent on that ocean water. Okay, that is all that I have for you guys today. Tomorrow you're going to be doing this biome research project, but that's it for now. I hope you enjoyed. Have a great day. If you have questions, email me, and if not, I will see you back here tomorrow.